Hello everyone, we are going to work out level 4 revision questions on 2-dimensional and 3-dimensional shapes adapted from November 2014 and 2016 level 4 paper 2 questions. Questions will include the ability by students to convert from volume to capacity, for instance, cubic centimeters to liters. David makes plant pots from cement and paints the outside of each pot. The square base is not painted. The pot has a side length of 34 cm and the height of 40 cm. As indicated here, this side is 34, this side is 34, and this height is 40. So if you look at this particular pot, we will have 4 areas that are the same, or 4 faces that are the same. We have this face and its opposites is 2, 3, and its opposite becomes 4 faces. Their area are the same because they are 34 centimeter multiplied by the height, which is what? 40 centimeter. Now the question says, convert the height of the pot to meters. So we are going to convert the height of the pot to meters. What is the height of that particular pot? It's 40 centimeter. So you divide it by 100, then you get what? 0,4 meters. So converting centimeter to meters, you simply divide by 100. The next question, calculate the total outside surface area in square meters of the pot, excluding the base. If the area of the top edges is 0,05 square centimeter. So let's see how we do it. The total surface area there will be the 4 faces as multiplied by the length multiplied by height. Remember we said we have 4 faces that are the same. So it will be those 4 faces multiplied by length multiplied by height. Of course, you also have to add what? The edges that we are already given here. The edges, we are told they are 0,05 square meters. So now the total surface area will be 4. What will be the length? We are told that the length is 34 centimeter. So we are going to take 34 centimeter divided by 100. So by doing so, we are going to convert that to meters. So we are converting 34 centimeter to meters. So it becomes 0,34. Then you multiply it by 0,4. Of course, we are going to add what? Those edges, which is 0,05. So by multiplying 4, multiply 0,34, multiply by 0,4, we will get 0,544 plus the 0,05 of those edges. And the total will give us what? 0,594 square meters. So that will be the total surface area of that particular pot. The next question says, if 1 liter of paint covers 5 square meters, calculate the quantity of paint needed to paint 30 pots. Let's see how to get that. We need to paint 30 pots. So what are you going to do? We're going to have the total area of 30 pots. What is the total area of those particular 30 pots? Is you multiply 30 by 0,594. Remember, 0,594 is the total surface area of 1 pot. So if you multiply them together, it will give us the total surface area of 30 pots, which is what? 28,2 square centimeter. Now, what will be the paint required? Remember, 1 liter paints 5 square meters. So we will take the total area and divide it by the 5 square meters where we are going to paint. And it's painted by what? 1 liter. So we are going to say 28,2 divided by 5. The 5, remember, is what? The area where 1 liter can paint. So now the answer will be 5,64 liters. So it will require 5,64 liters to paint all those particular 30 pots. But of course, we have to round up this particular answer to 6 liters in case there is spillage of that particular paint, so that that particular paint can be enough to paint all the 30 pots. If 1 liter of paint costs 159 rand 99 cents, calculate the cost of paint when painting 30 pots. Now we are going to see what would be the cost when painting 30 pots. Let's see how you're going to get that. The cost will be, of course, the cost of 30 pots will be, you will take 159 rand, the price of 1 pot, and multiply by 6 liters. Remember, 6 liters is required to paint 30 pots. So you multiply it by 6 and the cost will be 959 rand 94 cents. Now the next scenario there is given as a cylindrical container used by makers of Just Juice. The label pasted around the container does not overlap. The diameter of the container is 7 centimeters and its height is 13.5 centimeters. The diameter is indicated there, 7 centimeters, and the height there is 13.5 centimeters. So what do they mean when they say the label does not overlap? The label is going to be attached to the curved area of this cylinder. So when they attach it, it does not go on top of where it has started. So it exactly ends where it has started. So that is what they mean when they say the label does not overlap. Use the following information to answer the question that follows. Pi is given as 3,14. We are required to use 3,14 and you will be penalized if any of the value is used. You only use 3,14. The volume of the cylinder is pi r squared multiplied by height. The circumference of a circle is 2 pi r. Calculate the volume of the tin in milliliters if 1 cubic centimeter is equals to 1 milliliter. So now we are going to calculate the volume. The volume is given as pi multiplied by r squared multiplied by height. So to replace pi, we write 3,14, and to replace r, we replace it by 3,5. Remember, the diameter is given as 7 meters. I beg your pardon, centimeters. So in order to get the radius, what are you going to get? We are going to divide 7 centimeters by 2. So it's going to give us 3,5. So that volume will be 3,14 multiplied by 3,5 squared multiplied by the height. The height there is 13,5. So the volume therefore is going to be, if you multiply everything there, you're going to get 519,2775 cubic centimeter. That will be the volume. Now what will be the capacity? The capacity, we are told that 1 cubic centimeter is equals to 1 milliliter. So we'll replace 1 cubic centimeter by 1 millimeter and multiply this together, we still have what? 519,2775 milliliter. That will be the capacity that we are looking for. Determine the area of the label in square centimeter. Now, what will be the label? The label will be the curved area of that particular cylinder. So what will be the curved area of that particular cylinder? The curved area of a cylinder is 2 pi r multiplied by height. And therefore, the area will be 2 multiplied by pi is 3,14, r is 3,5, multiplied by height, which is 13,5, which is going to give us 296,73 square centimeter. Now the next question says, if the dimension of a sheet of printing papers are 135 centimeter by 56 centimeter, determine the maximum number of labels that can be printed from one sheet. Here we've got a sheet with this particular dimension. So we want to know how many of those labels that are going to cover that particular cylinder will be. So in other words, what do? We're simply going to find the area of the whole sheet. The area of the whole sheet. So what will be the area of that particular sheet? It will be 135 multiplied by 56, which gives us what? 7,560 square centimeter. Now, what will be the number of labels? The number of labels will be, we take the area of the whole sheet and divide it by the area of a sheet that is covering the cylinder. So it will be 7,560 divided by 296,73, which is going to give us what? 25,47. So the maximum of those particular labels will be 25 labels. So it means in the area of this particular sheet, there will be 25. It will not be more than 25. Hence, here we've got this as a fraction. So that fraction does not make a complete label. So it will be only 25 labels that are required for that. Now, use the picture below to answer the question from your prescribed book, page 141, and do as many questions as you can on 2-dimensional and 3-dimensional shape. Cheers.